Thank you. Good afternoon. First of all, thank you very much for the invitation. It's an honor for me and for my institute to be here with a smart public. Thank you for that. So, I will present to you some slides about our institute, and then a look into the future and the CENTI's role on that future. So, CENTI is a research institute in the north of Portugal. Was founded by 3 universities and 3 technological centers. 3 universities, the main universities in the north of Portugal, and 3 technological centers related to textiles and garment, related to leather industry, and finally with automotive and aeronautic industry. We are focused on automotive and aeronautic industries, construction and architecture, and finally health, protection and well-being, including sports. Our activity is not only R&D activities, research and development, but also to help companies to prototype and then to help them to go to the market with the first series. So we make some kind of co-production of the first products, including the technologies we are developing. What's strange in our institute is the fact that we are not working only with normal materials like polymers or glass and so on. We are working with several substrates and several base materials like ceramics, paper, leather, and so on. Why? Because we were born to support our industry. And we have several sectors, of course, in our region. 50 researchers, more 10 to 15 students, and till now, from 2009, we had 14 fundamental R&D projects, 90 industry-driven, and we applied for 25 patents. So, future. Future. We are afraid about oppressive technologies. I cannot realize a car, a BMW, with that kind of complexity. We think that the future will be simple, very simple, quite clear. Safe, of course. Safety is a very important question for automotive industry. Also sustainable and cost-effective, of course, but feasible. The point is, our aim is not to develop new materials without any possibility to go to industry and to be produced, to be put on the market. So, we are taking care also about these kind of oppressive processes. So the idea is to develop new or to improve former process in order to be very simple. So, smart materials we are developing are addressing these points. Clear design, clear cleaning, the aggressiveness of buttons and so on, new seamless design to remove workspace and create living space, and so on. So this is the basis of our concerns and our objectives in order to develop the right smart materials. So smart and functional materials are the real aim of our activities. In one hand, to integrate functionalities directly on the materials, and in other hand, to add some electronics, some smartness to the materials. I will explain this with some examples. Okay. So, first of all, we work with nanoparticles, nanofibers, and nanocoatings. First part, the fundamental part, how to develop new nanoparticles in order to obtain new materials, new functionalizations. So you have the capacity to develop and to make the synthesis of nanoparticles. Second part, special fibers. We have the chance to have the only one facility in Europe to produce 3-component fibers. It means we are able to put 3 different polymers in the cross-section of a fiber. For instance, in the right up part, you can see a piezoelectric fiber. Why? Because we combine 3 different polymers, 3 different materials in order to obtain a piezoelectric effect in a fiber. So imagine your clothes, and when you press your clothes, you are producing energy. Third part, surface functionalization. Of course, our approach, why nanotechnology for that? Because we respect the natural materials. Imagine wood without wood touch, or clothing, or leather. So the approach is to use a very, very thin layer of functionalization material in order to obtain the function without affect the natural and good characteristics of the surfaces. So we put on the substrates, the base materials, some kind of addition to obtain the function. You can see here, we reach ultra high hydrophobicity. And this test is very interesting because the drop have more affinity with the needle than with the textile. So it returns with the needle. It's very, very important, this property, because we are able to repel all kinds of water, blood, Coca-Cola, why not, coffee, and so on. Here you can see exactly a prototype with 2 functions. One is visible. The repellency is visible, and you can see the shape of the drop. The shape is round. It means the repellency is very, very good. At the same time, this prototype have a fully printed heating system in the other side of the textile. So another application, we exploited the photocatalytic effect on textiles and leather in order to obtain a self-cleaning effect. This is a prototype, this is a bus running in the north of Portugal to test finally that solution. We are very, very confident that in the future, for instance, in car sharing applications or in family use applications, self-cleaning will be a very interesting function for textiles and leather. Another example is all things related to thermal management. Breathability, thermal management, water repellency, management of the flow of air and so on are very, as you know, very, very important for comfort and health inside the cars. And finally, some functional solutions related to microorganisms. So we are trying to develop some strategies in order to avoid the growth of microorganisms inside the cars. Next one, printed electronics. Printed electronics is the base of our capacity in terms of smartization of textiles. And you can see here direct printed sensors and actuators. It means, for instance, a seat, a car seat. We can avoid all cables. Why? Because we are able to print sensors, heating bands, circuitry, or light emission elements in order to avoid completely cables inside your car seat. Printed and integrated lighting devices, stretchable circuits, very important. This is very important because the reliability of circuits must be ensured even when we are talking about textiles, fabrics with elasticity very high, and printed flexible sensor actuators, a matrix, in this case, hybrid electronics. And we have made some experiments, and that possibility is now confirmed, to introduce electronics, printed electronics, during the IML injection, mold injection. So it means that we are able to put the electronics in the moment we are injecting on textiles to obtain, in that case, a pillar. So hybrid smart systems, of course, it is necessary to include some more conventional electronics and the interface with other systems. Some cases of printed lighting. We are using electroluminescence, LEDs, OLEDs, and a few words about some techniques we are using. In the left case, it is a printer to allow us to print in a very cheap way, roll-to-roll printed electronics. I mean, for those not familiar with that technology, we are not talking about printing circuitry. We are printing the elements, printing the active electronic components. Some examples. In this case, we have electroluminescent materials inside that part, the panel. This is the A-pillar, including a sensor, and then, a sensor and light emission elements inserted during the injection molding. Some composite integrated printed electronics. In the right part, you can see vibration sensoring using printed electronics. Next part, the last slide, to show you some items, some technologies we are now ongoing work. So directly integrated actuators, components, materials on multiple surfaces, integration of customizable smart lighting, reducing the number of electronic components and structures in molded parts. Haptic systems provide feedback user interface using seamless integrated systems, and gesture recognition and interpretation systems avoiding contact with surface materials. Of course, mainly this last one relates to the question I put on. Of course, we are developing technology, we are developing the materials and the algorithms, but of course, till the end, till the market, we have some concerns. We have to involve more people, why not from the social sciences, in order to obtain the right intervention of this kind of smart materials in our daily driving. So please don't hesitate to contact me, and thank you again for coming and for paying attention to my presentation. Thank you.
Thank you, Anthony. Thanks.